We need a scheduling policy when we have many jobs to run or we are limited in resources. It needs to solve three limitations of the system. A. There are a finite number of resources such as disk drives or printers. B. There are locked resources, so they cannot be shared with another job. And C. Some resources may need the user to reassign jobs. We want a policy that can deliver the maximum throughput, provide quicker responses, and ensure fairness for all jobs while also maintaining an efficient CPU service. One thing we surely don't want is resource hogging. This means a job can be very selfish and make use of all the resources and not share them out. We may need to intervene to make sure we can get a hold of resources for ourselves, so we need a predefined point to intervene. Incorporating time slicing or priorities of jobs presents two types of schedulers, known as both preemptive, this means giving the power to interrupt the job, or non-preemptive, meaning we have to wait for the job to complete before we can do anything. A processor scheduler relies on an algorithm, an ordered set of instructions, to allocate the CPU and move jobs through the system. They are either preemptive or non-preemptive solutions, and each has their pros and cons. FCFS, or first come first serve, is non-preemptive, so it has to wait for jobs to finish and handles jobs based on their arrival. The earlier they appear, the sooner they get served. Now, this would be fine for a simple batch system, but in terms of response time, it would not be sufficient when using an interactive system with multiple jobs to handle. This can seem unpredictable and contains an element of chance when considering turnaround time. So if job A was 10 times slower than job B and C, and it would have been more appropriate to process jobs B and C first, this would not be feasible. SJN, or shortest job next, is also non-preemptive, and as the name suggests, runs the smallest jobs first. In order to function, it needs jobs to exist in the queue and have accurate runtime estimates of the jobs. Priority scheduling is another example of a non-preemptive algorithm and places priority to certain jobs based on precedence. So admin jobs would be ruled over basic user jobs. It also takes into consideration the resources that are required and how long it has spent in the queue. Shortest remaining time is a preemptive version of SJN, so this means it has the power to interrupt a job being processed and favor a shorter job to replace it if it is in a waiting state. And finally, a well-known algorithm named round robin that is used in interactive systems. It predetermines slices of time that can be given out to each job to ensure the CPU is equally shared out. A time slice is called a time quantum, and the size of this quantum is vital when taking the system performance into account. When a time quantum expires, the job is changed whether it has completed or not. It will then wait in the queue again to receive its new quantum. Multiple level queues aren't a scheduling algorithm, but more of a package that works in conjunction with several of the policies, taking benefits of them all with one queue per policy. It has multi-priority, variable time quantums, and an aging queue. So, now we know how resources are shared over a single process. How do we cope with multiple processes? There needs to be synchronization so that none of the following problems occur. Deadlock is the problem where no process is willing to release their resources, so everything is in a locked state. This means nothing is happening and is a real problem. Live lock does release resources, but returns to a locked state, also an issue. When two processes are competing for the same resource, it is down to luck as to who gets it. This makes predictable execution impossible. Starvation means that a process is always getting what it wants, while the rest have to wait and not receive resources. And with that, we have covered the basics of a processor and how it is managed by the operating system. This has been Sean, and in the next tutorial, we will be looking at the device manager and its basic functions. Please do not forget to subscribe to the SMKS channel or visit the website at www.smks.co.uk.